couple things here. Written on the far right side over there on the board. Don't forget that tomorrow being Thursday, we've got two things going on. Number one, we've got our DMR5 quiz. So that is over the same material that you've been practicing here for the last 5 minutes. That will be at the start of class tomorrow. And then towards the end of class tomorrow, we'll be doing Concept Quiz 5. And Concept Quiz 5 covers solving linear equations and inequalities. Basically, we were working on all of last week and then the start of this week as well. Okay? And then don't forget that on that Concept Quiz 5, you guys are allowed to use a calculator. So please bring your own calculator with you, and you can use it to do whatever arithmetic you need to do on that quiz. You good? How'd this go? You guys getting into this? Working? See how this went. So number one, there's just a single operation. Are you guys, again, in the practice of just doing this automatically? You see minus and negative, you just go plus a positive. I hope you're doing. Sorry? Oh, sorry, it's frozen. How about that? You guys in that habit? Minus and negative is plus positive. Okay, so let's go through. What is negative 9 plus 7?
-2.
And then negative 2 plus 10 is?
12.
Negative 2 plus 10 is not 12. It's 8. And 8 plus negative 19 is? Negative 11? You guys okay with negative 11 there? Any questions? Okay then. Number 2 is not as simple as number 1. There's obviously a lot of operations going on there. So we can't read from left to right. We've got to read according to PEMDAS. So we're going to do the work in the parentheses first. So I've got 7 minus 5. And then inside there, 4 times 2 is 8. Minus, what's the absolute value of negative 11? 11. And we're still squaring that. Please remember that you cannot square anything inside those parentheses until you've simplified everything within those parentheses. So let's go ahead and do the 8 minus 11. That's negative 3. What is negative 3 in the parentheses squared? 9. So it'd be 7 minus 5 times 9 plus 14. 5 times 9, of course, is 45. We've got to do that first. And we can finish off with the addition and subtraction. 7 minus 45 is? Negative 38. Plus 14?
Negative 24.
There's your final value, negative 24. Got it. Okay, so take a look at what you have for numbers 1 and 2. Take a look at what I have. We agree? I hope we do. Any questions? Okay, fair enough. Then in number 3, we're supposed to simplify completely. Do you guys see any distributive properties? We want to do those first. You don't see any?
Don't.
What? Anybody else? Anybody else see any? Yeah? Negative 5, yep. Negative 5 gets distributed, and the 6. They both get distributed. The tricky one on number 3, yes. The tricky one, of course, is the first one. Negative 5 times 2 is negative 10. What is the very next symbol I should be writing? Plus. And it would be plus 5x. That's right. And then you distribute the 6, so that would be plus 6x squared minus 18 as you distribute that 6 across both. And then like terms is right. What is like the negative 10?
Negative 18.
Negative 18. So you end up with negative 28. What about the 5x and the 6x squared? Could I add those up? Why not? Why not?
They're not the same.
Why aren't they the same? I see it. Hey guys, quiet down a little bit.
6x has an exponent and 5x doesn't.
So 6 has a what?
Exponent.
Right, it's 6x squared versus just x to the first. That's exactly right. So I just leave those alone. 5x plus 6x squared along with that negative 28 would be my final expression. Okay, lastly, number 4. Oh, question, I'm sorry. Noel?
Does it matter what order you write your answers in?
Right now, no. I don't really care. Later on, though, you don't want to go in descending order of the powers.
That's what I do.
Yeah, so if you wrote 6x squared plus 5x minus 28, you're a little ahead of the game. Later on, that'll be an important thing. Right now, it's not that important. But it'd be okay if you do that, of course. Okay, any other questions? Okay, so then number 4 is supposed to solve, right? Nick, what would you do first if you were going to solve number 4 for x? Add 7 to both sides. Agreed. So, Nick, when I do that, I get 8x over here. The 7's that out. What about the right side? Yeah, it's kind of hard to see that. I'll write it up here. 8x equals negative 16. Agreed. And then, Jaden, what would I have to do to finish this off? That's exactly right. Nice work. And we end up with x is equal to negative 2. That's our solution for that equation. That's what makes it true. You can always check that to be for sure. I think it'll work out fine. Hey, again, look at what you have. Look at what I have. If we are all in agreement, it's fantastic. I would love tomorrow, after I grade your DMRs, at the top of the little grading column, put make all grades 100 out of 100. I think you could do it. I really do. It'd be awesome, right? To finish the week off with everyone getting 100. I think you could do it. And it'd be cool to have. Anyway, hopefully you'll do your best. One word here, guys, as far as tomorrow. As you guys know, every time we do the DMRs, I say, hey, does anybody have any questions or anything you want to talk about? Every now and then somebody will say something. But listen carefully. You might be the person that has missed something on every single DMR this week. You might have missed 1 or 2 or 3. You might have missed a lot of them this week. If that's the case, you might be inclined to prepare for your DMR tomorrow. I cannot think of a better way for you to prepare for your DMR than to go back and practice the DMRs we did this week. That would be your best course of action. You got all the answers. Just reprint out the DMRs and try those. Check to see how you're doing. You got videos. I'm making a video right now. You go back and watch the videos and see how they went and practice along with those. Lots and lots of options. I'd love to see you all get hundreds. Really would. Good? Okay, awesome. Hey, I've got a question for you. What'd you think of functions?
They're a little confusing, but yeah, I guess I know.
A little confusing. So, hey, man, I gotta say, I'm gonna pause the video. This was the video part right here. In the video, we talked a little bit about terminology, relation, function, domain, and range. And I hope that made sense to you. You can always go back and rewatch the video, and we'll talk about that a lot here today as well. We did one little example within that video, and I thought a great way to start this off would be to see how you're doing with the video material. So let's try this one right here. I'm going to kind of call on you guys to see how much you can help with these questions. If I could get this in the right place, that would be awesome. There we go. So let's see how this goes. For the relation or the relationship, and it lists all these points out there, we've got x's and y's, right? Negative 2, 3, and 4, 3, et cetera, et cetera, et cetera. It says list the domain and range. So I'm going to just write down here, I'm going to write domain and range. And I'm wondering if anybody could tell us maybe one member of the domain. Like what's one number you think for sure is in the domain of this relation? Go ahead, Ava.
Negative 2.
-2. So why did you pick -2?
Because it's the first number in the set.
And that means that's what stands for which letter, which variable?
X.
Yeah. So your x's go with domain, right? So -2, definitely part of the domain. What's another member of the domain? Go ahead, Kyrie.
3.
I disagree. I don't think 3 is a member of the domain.
Wait, no. I mean 4.
4? Okay, yeah, 4 works.
I'm
Oops.
looking at a different one.
You might be, you're probably ahead of me. I'm going kind of slow. So -2 is a member of the domain. 4 is a member of the domain. What else do you see, Ben?
I see 5.
I see 5.
Yeah,
Agreed. And there's one more, right, Coy?
yeah,
-7.
-7.
That's exactly right. So your domain is simply a listing of all the x values. It really is that simple. You have all the x values, that's your domain. And your range is the list of all the y values. You're right. So range here, well, there's 2 different 3s, right?
And there's 2.
And there's 2 different 6s. We don't have to list them like 2 different times. Then we just say the range involves a 3 and a 6. And that's it. You can say 3 and 3 and 6 and 6. I don't think I'd mark you off for that, but there's no reason to list them twice. Okay, so question number 1, or A, I guess it is, fairly simple. You just list the x's out for your domain, list the y's out for your range. The next question is a little bit tougher. Is the relation really a function? And this goes to what you saw in the video. What do you guys think? Is this relation a function? Ava's got an answer. Anybody else have an answer you think? 2 of you think you know this? So if your hands are down right now, does that mean you're not for sure? Not for sure? Okay, maybe. All right, Noel, what do you think?
I think it is a function,
Okay, so we say yes. And explain your answer?
because if you look at all the domains, none of them have this different values, all of them have the same value.
None of the domain. Say that again. None of the domain
Have different values, they all have
have
-2 is only equal to, or only, whose range is 3, it's not another number?
So can you think of a different way to say that? Because it's hard for me to write
Yeah,
that.
that's what I'm trying to figure out.
Yeah, think about it for a second. I think you're describing it fairly well, but I'd like it to be a little more of a brief because. Can I come back around to you?
Yeah.
Okay, keep thinking about what you want to say. Anybody else have maybe a, because she was like really touching on the right ideas. It was just hard to like get it out, sort of. Say it again, Chase?
There's only one output for the input.
Okay, so because there is only one output for each input, is that what you said? Because there's only one output for each input. Okay, well, let's look. So are the domains the input or are the domains the output? Yeah, domains are all the inputs. So, and this is where I think Noelle was going with this, and I think she was definitely correct. It was just hard to say. How many outputs does -3 or does 2 have? -2 have? One. Just has the one output. -2 maps to 3. 4 also maps to 3. It's the same number, but 4 only has the one output. 5 only has one output. -7 only has one output. And that's the definition of a function that we saw in the video. Function is a relation where every input has exactly one output. Well said. Okay, and then lastly, this is going to lead us towards something here at the end. Could you guys take a second and just plot all the points in that relation? Just use that little graph down below. Plot all the points. And we'll look at something, look at a pattern as we finish up our class today. You guys get something like that? Yes, sir.
Are you going to do like the test?
We're going to talk about the vertical line test. Yeah, yes, sir. We'll come back around to that. That's exactly right. Do you guys get a graph that looks about like mine? Roughly. Now, we don't know what's going on in between those points. What we're going to look at later, and this is what Chase was suggesting, is later on we're going to look at a vertical line. You could even like use your pen or pencil or finger to do this. And we will move a vertical line across the graph. And if that vertical line ever touches more than one point at a time, it's not a function. So can you see, if you took this vertical line and you swept it across the page, do you see how at every single point it would be touching at most 1 point? There's no places where that vertical line would be touching more than 1 point, like 2 or 3. And so another indicator that this is, yes, definitely a function. Okay, we'll come back around to that a little bit later. All right. We good? Let's flip ahead and see what is next. What do we got? Oh, yes. How about we do this? So I want to look at this. I call this a yes-no exercise. And this will kind of lead us back to this vertical line test. So the question is, does the graph represent a function? And on the left, I've written no. And then on the two graphs on the right, I've written yes, it is a function. So think about that vertical line passing across these graphs and think about how that would work. So is it a function? No. So that must mean that it fails that vertical line test, right? So if you took a vertical line and you... Oh man, I don't know if I can do it with this program. If I take a vertical line like this and I pick up that vertical line, which I don't know if I can do. Maybe I can. Maybe not. No, not with this program. Maybe I'll show you with a different program here in a second. Anyways, if I take that vertical line and I slide it across, so in other words, I move it from left to right, do you see how, like right in here, and all the way across the whole graph, do you see how the vertical line would be touching 2 points? Right there and right there? That means that that particular graph fails the vertical line test, and that graph is not the graph of a function. So then you could do the same thing with this, and this, and this, and you can see that no matter where you draw that vertical line, I keep drawing it on the same spot there. No matter where you draw the vertical line on that one, do you see how it'll never touch more than 1 point? Yeah? Same thing here. Oh, not vertical. Let me show you something a little bit different. I'm going to pause this. I'll show you a different look. As you look at these, do you understand the no, yes, no?
Yeah.
Picture that vertical line. You can even take your pencil, your finger, whatever. Like if I were you, you could take it and you could literally put it on your paper and take this vertical line and just move it across. Do you see it? And as that vertical line passes over the graph, do you see that here you're touching more than 1 point all the way across the graph, right? Here, you're only touching 1 point as you move across. Here, you're touching definitely more than 1 point, right? 1, 2, 3. Make sense?
Yeah.
Okay, so that's a vertical line test. That's what we were headed for there. And the final thing I want to talk to you guys about before we do a little practicing is function notation. And where do the inputs and the outputs of a function come from? Okay, so g of x is equal to negative 3x squared plus 7x minus 1. That is how you read this. I'm going to write this down for you. So this right here is not multiplication. This is the name of the function. So we would call this function g of x. Have you guys ever heard that wording before? Done functions before? Okay, that's great. We call that g of x. The name of the function is g. So this is the name, and x is the input. So that's the number that you're going to be, or that's the variable you'll be plugging numbers in for. So the name of the function is g, and the input is x. And then this over here, this is the rule, or the expression for g. It's the rule or the expression for g. So again, this is just different notation. Does anybody know, maybe you've had an algebra class where you've talked about this. What is g of x like? It's sort of a different variable. You could represent g of x with just a single variable. Everybody? No? Like what's typically the output in a linear equation? Usually it has x's and y's. So g of x has the same role as y. G of x is the output for the function. In middle school, did you guys ever hear, like those of you that maybe had done some work with functions, did you ever hear of it as called like a function machine?
Yeah.
So let's maybe talk about it like that, and I'll show you some examples. So sometimes people think of these functions as function machines. So let me draw you a little picture of a machine over here. So you've got this little area where something gets input into the function. Here's the machine, and the inside the machine are all kinds of like gears and pulleys and things like this, and little conveyor belts and little levers that get hit, and this little conveyor belt here at the bottom or whatever, you know. And what you do is you drop stuff into the machine. The machine, beep, 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 you know, does all the stuff that it's supposed to do, and it spits out an output. You ever hear this analogy before? So every function machine has its own little name. Like just like any machine might have a name. Like a toaster is a machine. It toasts bread, right? A refrigerator is a cooling machine that cools stuff that needs to be cooled. So this machine is not cool like a refrigerator or a toaster. This is called the g of x machine. That's the name, right? So the g of x machine is going to take any inputs, and it's going to run it through this. That's the machine part, and it's going to kick out an output. So let me just give you an example. What if I took, I don't know, the number 1? What if I took the number 1 and dropped it into the machine? Let's think about what would happen. So if I take a 1 and I drop it in the machine, all the little mechanical stuff that's happening in there, here's what's really going on. I'm saying, all right, well, let's take a 1 and let's put it in place of x. And what that machine is going to do is it's going to be like, okay, I'm going to square that number. I'm going to multiply it by -3, and then I'll add a 7 and blah, blah, blah. I'll do all this stuff to it, and we'll get this output. So what's 1 squared? Times -3 is? All right. No, just -3. 7 times 1 is 7. So -3 plus 7 is 4, minus 1 is 3. So I dropped in a 1, and what came out?
3.
A 3. So the input was 1, and my little function machine did its stuff, made all of its little mechanical noises, and out came a 3. So the input was 1. In other words, the domain was 1, and the output was 3. We'll practice the mechanics of that here in a second. That's the idea of a function. Yes?
So in the equation, the g of
Nope, it's just the name of it.
Alright, and then the x is the variable you're trying to find.
It's not that you're trying to find that. The x is your input. So I'm going to tell you,
Does it always have
You're gonna tell us.
I'm going to tell you, hey, what if x was 2? So in other words, plug in a 2. Or I'll say plug in a 4. So what you're really finding, I think Coy said it best, what you're finding is what's the output. I'm going to typically tell you what the input is, and you're going to have to find what the output is, or the y, I think is what Coy was getting at.
So it doesn't always have to be 1?
So say again?
It doesn't.
Nope, no, definitely not. So I could have said, maybe I didn't want to plug in a 1. Maybe, just maybe, I was interested in plugging in something really simple like a 0. So if I plugged in a 1, I got out a 3. If I plug in a 0, let's think about what happens. That would be negative 3 times 0 squared. Look at that. Those first two terms are just going to go to 0, aren't they? Just something times 0 plus something. So what's the output? Negative 1. So I plugged in a 0, and what came out? A negative 1. Okay, does that make sense? Are you guys picking up on the fact that this is just evaluation like we did a long time ago and what we've been doing on almost all of our DMRs? It really is just a different form of evaluation. So anyways, we got this function machine. We got a name of a function. And did you notice in number 1, we have a totally different name of a function? It's no longer named G. It's called F, but the input is still X, right? So the name is F, the input is X. So I thought I'd maybe do one of these with you and see if you guys can handle the rest. So if I'm supposed to use this f of x function machine, it says find f of 1. So here's what f of 1 means. Plug in 1 for x. That's what f of 1 means. It means wherever you see an x, you put a 1. Wherever you see an x, you put a 1. So I'm going to do that. So I'm going to use my function here. It's going to be f of 1 equals negative 4 times 1 plus 9. Notice how I just replaced the x with a 1. That's all I've got to do. Negative 4 times 1 is negative 4, and negative 4 plus 9 is 5. So I would say f of 1 is 5. I said this earlier. I'll say it again. This is not multiplication. So f of 1 is not multiplication. So please don't think that we need to divide by something at the end. Simply means this. Just like we said before, this means that the name of the function is f and the input was 1. So the name of the function is f, the input is 1. And what does this equals 5 mean?
The output is 5.
The output is 5. There you go. Well done. So the name of the function is f, the input was 1, and the output is 5. That's all that means. It's just a different way of expressing it. So what I'm hoping you guys can do then is, can you take a minute here, see if you can work with a partner if you want, see if you can find f of negative 2 and f of 6 using a very similar process.
All like the actual names for.
No, say it again.
All like the variables for the inputs to outputs, like 1 to 1, 1 to many, many to many, like all that stuff. Where does that come in?
So you can have a function that's 1 to 1.
Yeah.
And see how this goes for you. So you got practice questions here. So let's do, I don't know, let's just do all of them. I think you guys can handle all of them. I'll come back around here in a few minutes and we'll check your answers. Work together. See how these go for you. Ready to go. I've given you plenty of time to work this out, and I think you've had a good chance to do this. So for number 1A, list the domain and range. I'll just put the letter D for domain. My domain would be negative 1, 2, and negative 6.
It's on freeze.
Make sense?
Yeah.
My range would be...
Wait, what happened to the 2?
There was 2 2s. You only have to list it once. Range is 5. There's 2 8s, but I'll just list one of them, and negative 4. So there's my range. Make sense? So B is the relation a function. Explain your answer. So the answer for B is no. It is not a function. Here's why. It does say explain your answer. I do want to be really clear about this. I do expect you to explain it. The reason why I expect you to explain it, it's very simple. I think the way you practice is the way that you are going to perform. If you don't practice explaining it in class, you're probably going to fall flat on your face when you're trying to do it on a quiz, right? And so I'd encourage you guys to practice this. And that was the number one thing I had to do as I walked around. There's a couple that said explain your answer, and most of you were just like, don't want to do it. Be prepared to be disappointed. Be prepared to be disappointed if you don't explain your answer when called upon to do so. Let me finish my explanation here and I'll get your question. So as far as explaining your answer goes, I would say the reason why it's not a function is because the input of 2 has not one output, but 2 of them. So 2 outputs. So the input of 2 has 2 outputs, and those outputs are 8 and -4. Those are the 2 different outputs for the 2, meaning it's not a function because in order for it to be a function, every input must have exactly 1 output, and the 2 has 2 of them. Did you have a question?
Yeah.
Corey?
Could you say that the inputs repeat? Could that be an explanation? Or
Well, that's not a full explanation because what if I gave you a function that looked like this, where I'll just do this off to the side. This would be a totally different function. What if it was like 3, 6, 2, 5, 3, 6, and 4, 8. You could look at this and say, hey, the 3 is repeated, but look at the outputs are the same. So the 3 maps to a 6 regardless. So that's not enough evidence. You got to say that the 3, or in this case, the 2 has 2 different outputs.
Okay.
Yep. All right. Any other questions? That's a really good one. Anything else? All right. Hope this is going well for you. Number 2 gave us a function. This one was not named F. It was not named G. It was named Harry, Henry, Hector, whatever. It's the letter H, right? Harriet. There we go. Holly. So H of 2. Can anybody explain what H of 2 means?
It means that actually it was 2.
Yeah, the input is 2. So that's what I'm going to do. So this would be 3 parentheses 2 squared minus 5 parentheses 2. I'm trying to follow my good practice with evaluation using parentheses here. So when I do this, I get H of 2 is equal to 3 times 4 minus 5 times 2. This gives me H of 2 equals 12 minus 10. I got H of 2 is 2. So when the input is 2, the output is 2. And that means the point 2, 2 would be on the graph if I graphed H. That's something else that means. All right. Did anybody do H of -2?
Yeah.
What did you guys get for H of -2?
22.
22? Let's find out. So it'd be 3 times -2 squared minus 5 times -2. Just plugging in that -2 wherever there are x's. That's what that means. So this would be, well, gosh, what is -2 in the parentheses squared? 4. We've done this a lot. I'm hoping that it's catching on. Got 3 times 4. And then it would be plus 10, right, when I multiply the -5 times the -2. This gives me 12 plus 10, which is 22. So H of -2 equals 22. What does that mean? If you see this, H of -2 equals 22, it means a couple things. Number one, what does it mean? What equals 22? The input is -2. The output is 22, and the function is named H. That's all it means. Okay, and then finally we've got H of -1. Did anybody do this one and get it right?
Yeah.
What do you think?
8.
Positive 8?
Yeah.
Let's find out. So H of -1 is 3 times -1 squared minus 5 times -1. This would be 3 times 1 plus 5, which is 3 plus 5. I've got H of -1 equals 8. What exactly does that mean?
Means that the output is 8.
The output is 8.
Input is -1, and it's named, and the function is named H.
You guys getting it?
Good job, Ben.
Okay. Any questions? All right, final one here. Here we go. Which of the following represents a function? So this, as I walked around, almost everybody had yeses and nos all over the place. Not very many people had great explanations. So let's focus on that real quick.
I had such
So first of all, the upper left one, yes or no? We'll come back and we'll do the explanations in a second. So I agree with you, yes. How about the next one in the middle? Yes. And how about the last one? No. That's a no. That's a big no.
Why?
So let's talk about why. Let's start off with the no. You could say something like this. A vertical line intersects the graph in more than one point. In fact, how many points does a vertical line intersect that graph in? All of them, right? So a vertical line, as you move it across, would actually intersect, when it gets right there, would actually intersect that entire line. It would be an infinite number of points. Yes, ma'am?
So I just said does not pass the vertical line test with that.
I'd say that'd be kind of the basic explanation. I could go with that for sure. Doesn't pass the vertical line test, or maybe fails the vertical line test. Sure. So then maybe along those lines, kind of in that spirit, for these two yeses, you could say that both of those graphs pass the vertical line test. You could say something like that. So there was a lot of like very imprecise wordings. You know, there was like, well, hey, the thingamabob with the stuff does the thing to the point. And I'm like, I do not know what you're talking about. So make sure you're using good, clear language. I will not assume words in there to fix anything that need to be fixed. So those two pass the vertical line test. And then how about the other one, the final group here? This final group got three graphs, very interesting. So what do you guys say for the first one, yes or no?
Yes.
Yes, that is a function, agreed. How about the middle one? That's a no. How about the last one?
No.
Also a no. So these two fail the vertical line test? No. And yes, this one passes the vertical line test. So hey guys, let me do just a little brief thought on this. As far as connecting a function with a function's graph, let's say I chose an input on one of these graphs. Let's say the middle graph. Let's say I chose right here. Let's say I chose the input of 1. You see it right there, I wrote it in green. How many outputs does the input of 1 have?
2.
Aren't they right here and right here? What are the outputs exactly? If the input is 1, the outputs are?
1 and negative, or no, positive.
So 1, 1, and this point up here is? 1, 3. So do you see how the 1 has two different outputs? And do you see how that would fail the vertical line test?
Yep.
Do you see them? It's a good connection back to what we started our class with. Okay. I am finished, I think. You guys have about 10 minutes. You can work on WebAssign. I'd be happy to help you with any of that stuff. Don't forget that you've got concept quiz retries. The last day you can do them is 1 week from yesterday. So let's be thinking about those. Please be productive with our last 7 or 8 minutes.